Today's lesson is graphing a function, and so by the end of the lesson you should be able to say that I can graph equations that represent functions. And remember, when we talk about functions, we're going to start seeing function notation a lot, where we have f of x, like that, and part of functions is putting them in slope-intercept form, whereas it's that y equals mx plus b form. And so that's what we're actually going to do first for our warm-up is, we remember these were called literal equations, where we have multiple variables. And we're going to go ahead and solve this equation for y, which is going to have it resulting in our slope-intercept form. And so the first thing I want to do is we're going to subtract 10x to both sides. And I have 5y equals negative 10x plus 80. I'm going to keep it in that slope-intercept form as I work. Divide by 5 to every single term. And y equals negative 2x plus 40. And then right there we have our final answer. We not only solved for y, but we also put it into slope-intercept form, which is going to be very important for what we're working with today. The next slide is vocabulary, and I want you to go ahead and jump on Google and see what you can come up with for a definition for continuous graph versus a discrete graph. And then come back to check your answer. Hopefully, if you did a little research on your own, you'll see that a continuous graph is where the function can be any point. Function can be any point, while a discrete graph is your x values or your function can only be specific points. And then go ahead and look at these graphs. And so if you compare the graphs, a continuous graph is a smooth line of some kind. It doesn't have to be straight, but it's smooth and completely connected without any holes. And a discrete function has just select points or only parts of lines. It's not a continuous flow. And today our whole goal is to graph functions. And so we're actually going to go ahead and jump into our first example where we have to graph the function row. And so we have y equals 2x plus 1. Also, since we know it is a function, we could say f of x equals 2x plus 1. It really doesn't matter, but you might see both or either of them. And if you notice over here, we have a hint. It says to make a t-table to plot points. And that's always what we're going to want to do. And actually, when we do this, the best way to make it the table is to have your x a workspace, and a y. And in the workspace, you could put 2x plus 1 because that's what we're plugging x into. And so, because we're only doing the positives on this graph, I'm going to start with 0. 2 times 0 plus 1, we have 0 plus 1 gives us 1. 1. 2 times 1 plus 1, 2 plus 1 is 3. 2. 2 times 2 plus 1. 4 plus 1 is 5. 3. 2 times 3 is 6. Plus 1, we get 7. And so right here I have my t-table, and I filled it out. The purple was what I initially started with. And so I have my x and y points, and that's what I'm going to graph. And remember, you go over on the x, up on the y. So I'm going to go to the point 0, 1, 1, 3, 2, 5, 3, 7. Then I'm going to go ahead and connect my dots. Hope for a nice, smooth line. And notice we got a linear function. We have even jumps on both sides, so we have a continuous rate of change. And so we know that this is linear. Example 2 go ahead and graph it on your own. We have the function y equals negative 5x plus 12. And like last time, it says to make a t-table. So I actually set one up for you. If you want to go and fill it out, graph the function and see if it's linear or not, and then come back to check your answer. If you compare my work against yours, notice that we made our t-table, we graphed our function, even jumps, continuous rate of change. We once again have a linear function. Also notice a nice straight line. So for our next example, I'm going to go ahead and change the graph that I have. I'm going to make it into a 4-quadrant grid, because notice that now we have an x squared function, and we're going to want to give some negative and positive values. So if I'm going to make my table, y, I'm going to choose from -2 all the way through +2, so I get some both, image of the graph from both sides. So if I do -2 squared is 4, 4 plus 3 is 7, -1 squared is 1, 1 plus 3 is 4, 0 squared is 0, 0 plus 3 is 3, 1 squared is 1, 1 plus 3 is 4, 2 squared is 4, 4 plus 3 is 7. And notice that when I found the points for my table, look at what happened with my y's. 7, 7, 4, 4, and a 3 in the middle. So negative inputs should have the same outputs. And so if we would graph this, -2, 7, 1, 2, 3, 4, 5, 6, 7, way up here. -1, 4, 1, 2, 3, 4, 0, 3, 1, 4, and 2, 7. Notice what my graph looks like. We have a parabola. Parabola. And so whenever you see an x squared, your shape of the graph is going to be a parabola. And so you should have this type of shape. With example 4, go ahead and try it on your own. Notice I split my graph again into 4 quadrants, uneven 4 quadrants, but still 4 quadrants. And I'm going to ignore the regular graph that was provided. And I also made my t-table, and notice that I used not only negative values, but I also put in positive values, all centered around 0. So go ahead, fill it out, graph the function, and see if you get x squared. We should have something that looks like a parabola. See what happens. If you notice, when I found my points, -2 and +2 gave me the same value, as well as 1 and -1 gave me the same value. When I graphed it, I got my U-shaped parabola, and I'm good to go. Our last type of graph that we're going to work with today is an absolute value graph. And so we need to make a t-table. Once again, we're always going to make them. Absolute value, x plus 2, y. And remember, when we work with absolute values, your outcome is always a positive number. So if I plug in, we'll go from -2 to 2. I have the absolute value of -2 plus 2. Well, that's -2 plus 2 is 0. Absolute value of 0 is 0. Next, I have the absolute value of -1 plus 2, which is 1. Absolute value of 0 plus 2 is 2. Absolute value of 1 plus 2, 1 plus 2 is 3. And the absolute value of 2 plus 2, 2 plus 2 is 4. So I have -2, 0, -1, 1, 0, 2, 1, 2, 2, 4. However, absolute values, we should have 2 distinct sides, and right now we only have 1. And so let's go back a few values. Let's put in -3. So value, -3 plus 2 is -1, gives us 1. -4. -4 plus 2 is -2, which we get 2. So -3, 1, -4, 2. Notice what's happening. We not only had this line off to the side here, we also have it going in this direction too. And an absolute value graph will always give you a V. So something to know, if you don't have a V, maybe try a few more points. So go ahead, try this one on your own. Don't forget to make your t-table. Absolute value of 2x minus 3y. And remember, we want to end up with a V. And also, whatever is absolute value, it will always give you a positive value. Notice in my t-table, I chose some positive, some negative values. I found their y, or their output, put it on my graph, and I ended up with a nice V for my absolute value, and so I graphed it correctly. Next, we have an application problem. So, a truck held 24 chairs. Let's annotate a little. You remove 2 chairs at a time. The number of chairs n remaining after you make t trips is represented by what equation? If you notice, I wrote an equation. The number of chairs left is 24 original chairs minus 2 chairs per trip. And so now that we have an equation, we know to make a table, and t is really the x. We have our equation, and n is kind of like the y. So go ahead, figure out some values and plot it. What kind of graph is it going to be? Notice I made my t-chart. I plugged in 0 in positive numbers. And if you think about it, because if t are the number of trips, you can't make negative trips where you bring more chairs. And so I also rebuilt my graph. I labeled my axes to make the best use of my space. I have labels, and I plotted my points. And notice I have a nice straight decreasing line. And if we look at our function, the t has a positive exponent of just 1, and so we know right away it's going to be a linear graph, and it should give us a nice straight line. And finally, example number 8 is one more application problem to try on your own. So go ahead, read the problem, make an equation, a table, and graph it, and then come back to check your answer. So, if you notice, I have my equation, table, I restructured my graph to make it fit better, and I graphed my equation. It's a nice straight line or linear. And notice my variable has an exponent of 1, and so I know it should be linear, which means I hopefully did it correct.